Okay, I'm recording you guys, okay? So, look at what we're starting. Exponentials. And what goes hand in hand, you guys, with exponentials? Logs. Logs. I was waiting for moaning. Who says, I don't like logs? I do not like logs. If you don't like them, then own it. Okay, raise your hand. I do not like them. So, I used to hate them. I used to be like, I don't get this. Like, I just think they're so awkward or whatever. You guys, they're so easy. I'm telling you, all you have to do is memorize all the little rules and apply the rules. That's all you have to do. So, if you know the rules and you know how to apply them, you can do it. Okay? All right, here we go. First, we're going to graph exponentials. Okay, so look at that first graph. Look at the top one and look at the bottom one. Both of those are exponentials. The guy on the top is exponential growth. The guy on the bottom is exponential decay. They have tons and tons and tons of things in common. Okay, the things that are different is if your base is bigger than 1, it's a growth. If your base is between 0 and 1, so basically less than 1, it is decay. All right? Both of them, this is what they have in common, you guys. Both of them have an asymptote right there. Okay? If your asymptote, you guys, is right on the axis, extend that asymptote really long so we can read it. Okay, so you guys, everybody look at that red line and everybody talk to me out loud. Does that red line cross the x-axis or the y-axis? Here's my red line. Does it cross the x or does it cross the y? Tell me. Crosses the y. So everybody write y equals on both those asymptotes because they're in the same place. Where does it cross the y asymptote? 0. Y equals 0. Okay, look at the top graph. Domain is x. Start small. So if you're over here really small versus moving to the right, everybody in the room tell me the domain of that top graph. Everything, right? All real numbers, negative infinity to infinity. Range is y. Start low on the y's. If I'm really far down low, does that top graph touch my y? No. But as I move forward, tell me the smallest y that touches my graph. Doesn't touch it, right? That almost touches the graph. 0. How do I close my 0? With a parenthesis, not a bracket. Why not a bracket? Never touches it, right? So it's 0 to infinity, okay? The y-intercept is right here, and that is the ordered pair 0, 1. The asymptote we already wrote. Okay, look at this one. Look at the bottom graph. Everybody in the room, all 35 of you, tell me what the domain of the bottom graph is. It's all real numbers, the same as the top one, right? Look at the range. That's y. Start low, move up. What's the range, everybody? Same thing, right? 0 to infinity. The y-intercept is also the same thing. It is still 0, 1. And the asymptote is the same. So there's tons and tons and tons of things the same, okay? Listen what you don't have to do. You don't have to do this. Oh, my base is bigger than 1, so I know it's going to swing this way. Oh, my base is less than 1, so I know it's going to swing that way. You don't have to do that, okay? You don't have to do that. It just naturally happens, okay? So everybody look at this one. Y equals 2 to the x power. Oh, by the way, go back over here for 2 seconds, and I want you to write this down somewhere. For both of these graphs right here, this is the most important thing. First of all, they both have an asymptote at y equals 0. Okay? The other thing I want you to know is the point 0, 1 is present on both of those graphs, and the point 1, a is present on both of those graphs. I'm telling you guys, those are the only 2 points I plot because I can do it with just those 2 points. Okay, let me give you, look at this top graph, look right here. If I have my pencil at the origin, if I go right 1, how far up did I go? 2. So I know the equation of that exponential is y equals 2 to the x. This guy right here, I went right 1, and then I went up. What does that look like? It looks like a half, and it is a half. So you have to put the half in parentheses, and it looks like that. Okay? Okay, now let's go back to this problem right here. Y equals 2 to the x. Okay, everybody look right here for 2 seconds and stop. Okay? Look at this. Y equals 2 to the x minus 3 plus 1. That is not apparent. Why is it not a parent graph? Because you have all those adjustments. Does y equals 2 to the x have any adjustments? No, that's a parent, okay? So I want you to write down the word parent right there. There are no up, down, right, left reflections. There are no changes, okay? This is not a race. Please don't think I'm trying to make this into a race. But I'm telling you, you're going to be able to graph this thing in about 30 seconds, for sure. This is what you do. Look how easy. You say, I know it's a parent graph, so I know I'm going to have an asymptote right there. I know I'm going to hit the point 0, 1, because I always hit the point 0, 1. And then if I go right 1, I go up whatever my base is, which is a 2, and then I'm like, okay, now I have the general idea of what that graph's supposed to look like. There it is, and I'm done. Literally, that's all you have to do, okay? Now, they do give you a table. I think the table is completely lame because the point of a table is usually to help you graph it, but I just graphed it and I didn't even need the table. Do I think they're going to give you a table? No. Am I going to give you a table? No. But if they do, we better be ready for it. Okay? So what if x is a 0? 2 to the 0 is a 1. What if x is a 1? 2 to the first is a 2. What if x is a 2? 2 to the second is a 4. What if x is a negative 1? Can anybody tell me what 2 to the negative first is? The 2 to the negative first comes down, right? So it would be, what would that be? 1/2. Yeah. 1 over 2 to the positive first, right? What is 2 to the negative second? What's that? Yeah, the 2 to the negative second comes down, so it would be 1 over 2 to the second, and that is 1/4. Okay? Now take a look at your graph that you just graphed. The next, put your pencil at the origin, and you're supposed to go right 2 and up 4. If your graph is a little bit off, erase it and make it a little more accurate over there. But the 2 points that I really care about, you guys, are that point and that point. Okay, that's it. Okay, let's do the next one. Y equals 1/2 to the x power. So this is important. This question right here is important, so I want you to look. Y equals 1/2 to the x power. So I go, okay, I know it's a parent, so I'm going to have an asymptote. And I know it's going to hit the point, I know the point 0, 1 is going to be on there as well. And then I know if I go right 1, I'm going to go up whatever that base is, which is 1/2, so it's right there. Okay, now everybody freeze right there. This is why you don't have to memorize which way it swings. Because if I plot 1, 1/2, I go, okay, this is weird. It's lower than my first point. Then you go, okay, well then that means it's going to swing this way. So on the other side, it's going to swing up. Now I'm going to show you a little trick. See the 1 over 2? Flip it upside down, and you have 2 over 1. If I go left 1, I go up 2 over 1. So it's going to be like that. Okay, we'll talk about that more in a second, but that's it. Okay, let's fill in this silly table. 1/2 to the 0 power is a 1. 1/2 to the first power is 1/2. This is why it's 2 over 1. Write this down, okay? Everybody write 1/2 to the negative first. So that's 1 to the negative first over 2 to the negative first. But you can't have negative exponents. So the 2 to the negative first comes up and becomes a 2 to the positive first. The 1 to the negative first comes down and becomes a 1 to the positive first. So I have 2 to the first over 1 to the first, which is a 2. So that's why I flipped that guy upside down, and that's how far I knew to go on the other side. Everybody in the room, tell me, what is 1/2 to the negative second power? Do you know?
4.
It is a 4. Yeah. Good. Okay, let's do the next one. Y equals 3 to the x. Watch how easy. 30 seconds. It's not a race. Y equals 3 to the x is a parent graph, so I know I'm going to have an asymptote right there. I know it's going to hit the 0.01. I know if I go right 1, I go up whatever my base is, which is a 3. I connect my dots. There's my graph. That easy. That quick. Who says gotcha? I'm totally with you. Let's see. Okay, great. Let's do the silly table. 3 to the 0 is a 1. 3 to the first is a 3. What is a 3 to the negative first, everybody? 1/3. Yeah. Done. Good. Okay. All right. This guy. 3 to the negative x. Okay. We're going to start with the parent, just like we did when we were graphing parabolas, and then we had to reflect and right and left and up and down and stretch and all that stuff, okay? So everybody write y equals 3 to the x power is my parent graph. And now graph that parent. So draw your asymptote, plot the 0.01, go right 1, up 3, there's my graph, that's my parent. Everybody in the room, if the negative is up in the exponent, do you think that that is a reflection across the x, or do you think it's across the y? Before you say that, the rule stays the same. So look right here for a second. Y equals negative x squared versus y equals negative x squared. Which one of those is a reflection across the x, the top one or the bottom one? The top one. So this guy's x-axis. And this guy's y-axis. The same rule applies over here. So do you think that guy's x or do you think that guy's y? Guess. If it was x, it would come at the very front. Okay? Let's write this down. Everybody write y equals negative 3 to the x. That is an x-axis reflection. If it comes first, remember I told you alphabetically, x comes before y. So if the negative comes first, it's a reflection across the x. It is not first here, so this is reflection across the y. Okay, write down the equation, y equals 3 to the negative x, and fold it across the y. Guys, if I fold the parent across the y, the right asymptote goes to the left goes to the right, so it doesn't change the asymptote. It also doesn't change the 0.01. The 0.13 goes to negative 1, positive 3, and it looks like that. Okay, that's it. Let's do the next one. Okay, everybody write down y equals 2 to the x power is my parent. Look how quick and easy it is to graph this, guys. You draw that asymptote. If you don't have an asymptote, you're going to lose points. It's almost as important as the graph to me. 0, 1 is present. Go right 1, up 2, graph it in. There's my equation. Now everybody write, oh, I put y equals, by the way. Let's grab our eraser and let's call that something like maybe f of x equals. So now I'm going to call this guy g of x is 2 to the x minus 3. And so, what is that? Is that negative 3 going to either move right or left, or is it going to do up or down? Which one? Right or left, right? Correct. So which one's it going to be? Right or left? It is right. Yeah, right 3. Okay, everybody look right here. I've got a horizontal asymptote. I shift it right 3. Have I changed my asymptote? Talk to me. No, asymptote doesn't change because it goes on forever. Here I'm at 0, 1. Go right 3. Here I'm at 2, 1. Go right 3. Curve it in. That quick. Done. Who says gotcha? I totally get all this. Let's see. Give me a raise. Let me see. Okay, good. Okay, this one. Okay. Everybody write g of x equals, in parentheses, 1/3 to the x. If you don't have parentheses around the 1/3, it's wrong. Because the 1 is raised to the x and the 3 is raised to the x, so you have to have parentheses, okay? Then write the word parent. The parent has an asymptote right there. The 0.01 is always present. You talk to me, guys. If I go right 1, how far up do I go? 1/3. And then I go, weird. I go, that's all right. It's going to be high on the other side. Take your 1/3. Flip it upside down, you get 3/1. That's how high up I go. if I go left 1. So my graph is going to be like that. So you don't have to memorize which way it goes. The graph, it just automatically happens that way. Okay? Okay, does the order matter of these transformations, the -3 and the +1? Does the order matter? No, but I do have a preference because I have a lot of students. What do I prefer? The up or down, yeah. So everybody write h of x equals, in parentheses, 1/3 to the x minus 2. When I graph, you guys, I always draw the asymptote first. So see that asymptote? Move it down 2. Always start with your asymptote. And then here I am at 0, 1, go down 2. Here I am, I'm going to do this guy. Left 1, up 3, and I'll take that guy down 2, and then I'm going to curve it, and there it is. Okay, final graph is going to be f of x is equal to, in parentheses, 1/3 to the x plus 1 minus 2. Talk to me about that plus 1. By the way, write down 2 right there. So what does the plus 1 do? Sorry. To the left 2 is correct, or left 1, sorry. Left movement on a horizontal asymptote does not change it. Here I'm at 0, -1, go left 1. Here I am at right 1, or left 1, up 1, and then I'm going to go left 1, draw it in. There's your graph. Okay? In question 3C above, what is f of 0? You guys are not talking about the parent. They're not talking about a single adjustment. They're talking about the final graph right there. Okay? So if x is 0, what is your y? Can you tell? Is it pretty clear? No, it's not. It's in between and I can't guess. Okay? So look what we're going to do. We're going to go y equals 1/3 in parentheses raised to the 0 plus 1. I'm going to put in a 0 for x minus 2. Now this is going to get just a little bit ugly. 0 plus 1 is a 1. 1/3 to the first is 1/3. So I have 1/3 minus 2. You could do it in your head. If I owe someone, well, if I owe someone, oh, I can't do 1/3 of a buck. That's 33 1/3 cents. If I owe someone 2 pizzas and I give him 1/3 of a pizza, do I still owe him or are we even? Still owe him. How much do I owe him? A full pizza, and then I only gave him 1/3. So how much do I still owe him of the partial one? 2/3. Right? So you can think about it. You can also get a common denominator of 3. Look right here. So it's going to be 1/3. This guy right here is 1 times 3 is 3, so 2 times 3 is 6. 1 minus 6 is -5/3. Same answer. However you want to do it. Okay? In question 3C above, if f of x is -1, what is x? So they're saying, look at the graph. If y is a -1, what is x? Guys, that's this point right here. So that would be the ordered pair, -1, -1. So if y is a -1, what's x? The answer is x equals -1. And then the question is, what point is on the graph? Well, I already wrote that point. It's right there. We've done that before. Right? Who says I'm good? I get this. Raise your hand. Good. First day of exponentials and logs, so that's good. All right. Now we're going to talk about E. Okay? E is weird. This is where you start feeling uncomfortable about logs and exponentials. Okay? Look right here. You know how pi, everybody write down pi right here. Pi is 3.14159, I think. Do you know more? Something, right? Is this scary or awkward to you anymore? No, you've done it forever, so it's not scary or awkward. See E, it's 2.718. That's all you need to know. So it's just like pi. Instead of 3.14, it's 2.17. 2.71, I mean. That's all. That's all you need to know. So it's not scary or weird. Okay? Everybody look at question 4. Let's write the parent. So everybody write y equals e to the x is my parent. It's a parent exponential. Look at all the things I know, guys. I know I have an asymptote here. I always start with asymptote. I know it's going to hit the point 0, 1. And I know if I go right 1, I go up. Awkward. What is it? 2.7. Yeah, it's not scary or awkward. It's just a decimal. That's all. Right 1, up your base. Up 2.7. Okay?
You're at 1.7.
Oh, yes. I saw some funny faces. I saw people going, huh? Now it's good. So I did almost 2 and I meant to do almost 3. Okay, let's do the last one. So it's y equals e to the x minus 3. Everybody in the room tell me what the minus 3 does? Down 3. So let's go down 3. Always start with the what? Tell me. Asymptote. Yeah, otherwise you're going to forget it. So just do it. Plus it helps you keep your bearings. So here you are at 0, 1. Go down 3. Here you are at 1, 2.7. Go down 3. I'm just a tiny bit below the x-axis. Curve it in. There's your graph. Done. Okay, this one. Let g of x be that. Determine the domain. Okay, well, let's graph it. Let's graph it, and then let's find all the other stuff. Okay, so they call it g of x, so let's call this guy h of x. So let's come down here to part C. H of x equals e to the x. That is my parent. Remember, you have to write the word parent. So draw that asymptote. 0, 1, right 1, up 2.7. There's your graph. Everybody listen to this. If there is a blank transformation, I must do it right now. What kind of transformation? A reflection, right? Look at the equation. Do I have a reflection? Yes. By the way, that equation looks so bad. I want to make it look good. So I'm going to go g of x equals. What can I do to make it look so much nicer? Flip it. Yeah. So let's write negative e to the x minus 3 plus 4. So guys, see this negative? That's the first transformation that I must do. Okay, so let's write down like m of x equals negative e to the x. Every person in the room, that negative reflects it across the, tell me everybody, it's the x. Yes, if it's first, it's x. So reflect across x-axis. If you have a horizontal asymptote on the x-axis and you reflect it across the x-axis, did you change your asymptote? No. So it's still just the same place. 0, 1 is now 0, negative 1. 1, 2.7 is now 1, negative 2.7. Draw it in. Okay. Do I care about the order of the rest of the transformations? No. But I would love you to go plus 3 next, so then everybody's the same, so it helps me grade faster. So I'm going to call this, like maybe n of x, I don't know. N of x equals negative e to the x, and it's going to be plus 4. So now I'm going to start with that asymptote, and I'm going to shift it up 4. I'm at 0, negative 1, I'm going to go up 4. I'm at 1, negative 2.7, I'm going to go up 4. 1, 2, 3, 4. So that puts me a little bit above a 1. So just be really careful that you're moving everything the right number of things. And this would be an up 4. Okay, and then I'm going to do my minus 3. Everybody in the room, tell me what the minus 3 does? To the right 3, yes. So let's go g of x equals negative e to the x minus 3 plus 4, and let's write right 3. I would love to put this on the next quiz. Does a shift to the right change a horizontal asymptote? Yes or no? No. Doesn't change it. So it's still at 4. And now I'm at 0, 3. And I'm going to go right 3. I'm at 1, a little bit up, which I think is a third, right 3, 1, 2, 3, there it is, curve it in, done. Okay? All right, look at this one. Here's a piecewise. Boy, this is a long lesson. Would someone please tell me what time the bell rings? Say it again. 27. Okay, we're good. We'll make it. What did you say, honey? Oh, yeah. Thanks. Look at the final graph. Thank you, honey. Tell me the domain. Domain is X. Everybody in the room, tell me. Everything. They didn't tell you how to write it. That's absolutely acceptable. Find all the intercepts. This is kind of tough. So we're going to go x-intercept, and then we're going to go y-intercept. Intercepts must be written as ordered pairs. If you didn't write it as an ordered pair on the midterm, they took off all the points. To find an x-intercept, let y be 0. To find the y-intercept, let x be a 0. So which one's going to be easier? Probably the y-intercept. So everybody go, g of 0 is negative e to the 0 minus 3 plus 4. So that's negative e to the negative third plus 4. It just depends on how much they want us to simplify. I think I would bring that negative third down. So it would be like that. And I'm going to say that's good enough. We could get a common denominator. I'm going to say we're good. So it's negative 1 over e to the third plus 4. You never put your answer in decimal form, ever. Unless what? Tell me. They tell you to do that. Yeah, never do it otherwise. Okay, this one's let y be a 0. I'm gonna skip it. Because it involves a conversion, which we have not done yet, so I'm skipping it. Okay? Okay, question 6. Graph the function. This is a piecewise function. Okay? Everybody in the room, I want you to go like this. Draw an XY axis, and I want you to graph in that parent graph. Y equals 2 to the x. Pencil at the, asymptote at y equals 0. Hit 0, 1. Go right 1, up 2. There's that parent. Okay? This first equation is y equals negative 2 to the x power. It means take that guy and fold him across the x-axis. So the asymptote's still going to be there, but now it's going to be 0, negative 1, write 1 down 2. There's your graph right there. But that whole graph is not supposed to be there. The only part of the graph that's supposed to be there are x's that are smaller than 0. So guys, look, here's x equals 0. Smaller than 0 is to the left, so the right I have to get rid of. If I'm equal to 0, am I on that graph? Everybody talk to me about that. If I'm equal to 0, am I on the first graph? Tell me. No. So that circle's going to be open. Okay? Now let's do the next one. So the next one is a double reflection. So it's a reflection across the x, which puts my guy right here. Okay, this one right here that I'm highlighting in yellow. Then I have to take him and reflect him across the y. The asymptote's not going to change. So take the original, reflect it across the x, doesn't change it. Then take it and reflect it across the y, doesn't change it. So the asymptote's still going to be the same. Okay, this point right here is 1, negative 2. So when I fold it across the other side, it's negative 1, negative 2. I'll draw this in blue so you can see it, differentiate, and it looks like that. That's a double reflection. Okay, but it's only supposed to be there if x is bigger than 0. So look, guys, here's x equals 0. Bigger stays. So smaller goes. So this is gone. Now let's see if you remember this. If I have an equal sign, I am on that graph. But the two graphs intersect at the same ending point. So if I have a closed that intersects with an open, is it open or closed? It is closed. You remembered. Good. Of course you did. Okay. State the domain and range. Let's do that really quickly. And find all intercepts, right? Okay, so let's do that really quick. This one's easy. So the domain, everybody in the room, tell me the domain. Everything. The range, start low. The smallest number on the y that hits it, what is it, everybody? -1. Does it actually hit it? Yes, so it's a bracket up to a, talk to me. 0, close with a parenthesis. Good. X-intercept. Everybody in the room tell me the x-intercept. There is none. And the y-intercept is very clear to see. It is 0, -1. Okay? All right. Now, there are lots of ways to solve these problems. Okay? We're going to start today by finding a common base. The base is this, just so you guys know. Look, if you have 2 to the 3rd power, the base is a 2. It's what's raised to the 3rd. Okay? So everybody look at question A. Okay? Everybody listen closely to this. Probably the most important thing right here. See, this base is a 3. See, this base is an 81. Some people say, they might say the 81's not a base. Yes, it is. It's an 81 to the 1st power. Okay? Take the big guy and turn him into the small guy. So see the 3, don't change it. Take the 81 and write it as a 3 to the something. Can you do that? It is 3 to the 4th. Yes. Okay, now listen to this. Off on the side, look right here. Could 2 to the 2nd ever be equal to 2 to the 3rd? Talk to me about that. No, they'd have to, exponents would have to be the same, right? So if I know that 2 to the x was equal to 2 to the 3rd, then I would know that x has to be, tell me guys, x would have to be 3. So come over here. If 3 to this equals, sorry, didn't mean to scratch that. If 3 to the x plus 1 is equal to 3 to the 4th, then I know x plus 1 and 4 must be equal to each other. X plus 1 equals 4, move my 1 over, x equals 3. That's my answer. Don't lie, but just tell me the truth. Raise your hand if you checked and checked and checked like crazy on your midterm. Who did that? Raise your hand, let me see. Okay, good. The final is even more important for that. You could check this question so fast, I could do it in my head. Look, if x is a 3, 3 plus 1 is 4, is 3 to the 4th, 81, bam. That was in my head, and it took me 7 seconds, okay? So absolutely checkable. Okay, let's do this one. Make the bases the same. Guys, look, this 5 is to the 1st, but it's on the bottom, and that's awkward. So I got to pull that guy up so they're all on the same level, right? So this is 5 to the x plus 3 is equal to 5 to the, can anybody tell me? It is negative first. If it's on the bottom and it's positive, pull it up and now it's negative. So now I know the exponents have to be the same, and now I move my 3 over and I get a -4. Look how fast I can check it. -4 plus 3 is a -1. 5 to the -1st is 1 over 5. Bam. Just check that. Or put it in your calculator. Okay? This one right here. Look at this. Everybody look at this. Right or wrong? That's wrong. The most common error on these problems is right here. Look what they did. Look. 125 to the 2x minus 1, they left that identical. The x squared plus 5, they left that identical. For some reason, they took that 5 and just randomly cubed it. Can you just randomly cube one side of an equal sign? No way. So that's not it. That is not what you do. Do you change the big guy or do you change the little guy? You try to change the big guy. It's way easier if you can change the big guy. Okay? So see the 5? He's not changing. So everybody leave that be. See the 125? I'm going to try to write that as a 5. But do you see the 2x minus 1? It's not changing. So the only thing I'm doing is writing 125 as 5 to the something. I'm just replacing it. What is it? 5 to the third. Now, to get this right, you have to remember the rules of exponents. Power to a power rule, what do I do to the 3 and the 2x minus 1? Do I add them or do I multiply them? You multiply. Distribute the 3 and you get 6x minus 3. Now I'm ready to let my exponents be equal. So now I know x to the second plus 5 is equal to 6x minus 3. Pull the 6x and the negative 3 over to the left, and I have x to the second minus 6x plus 8 equals 0. Does that thing factor? Yeah, this is actually an important question. Does this factor? It does. If I didn't think it factored, and I used the quadratic formula, would that be acceptable? Yes or no? Would I end up with the same thing? Yes. Big pain, way more, work, but acceptable. Okay, here we go. X and X, 4 and 2, signs are the same, they're both negative. I get X equals 2 and I get X equals 4, and I check them. Okay, don't have to, but you'd be crazy not to. Okay? Okay, question D. This is a 5, this is a 25. Which guy's bigger? 25. So I'm going to try to change him into a 5. Can I do it? Yeah. The square root of 5 is 5 to the what? Can you tell me? It is 1/2. Yeah. See the x plus 2 on the outside, guys? Not changing. The 25 changes to a 5 to the, talk to me, second. Yep. So I have 5 to the 1/2. By the way, look right here. Could I take that 1/2 and write it as 0.5? Is that acceptable? Is 1/2 exactly 0.5? Yes. So is it acceptable? It is. It's fine. I know they're not gonna, I know they're not gonna be mad about that. This right here is a 5. Power to a power, you multiply. You get 2x plus 4. So if 5 to this equals 5 to that, I know those must be equal to each other. So I have 2x plus 4 is equal to 0.5. Move my 4 over. 2x equals 3.5. Divide by x, and I think I get 1.75. Is that right? 3.5 divided by 2, or is it 7? Oh, yes. Oh, yes, it is a negative. Thank you. It is a negative. Thank you. Yeah, that's it. Store it, check it, good. Okay, here's question E. And it has a lot of E's in it. Okay, power to a power, multiply. 3 times x to the second is 3x to the second. This guy has e to the 15th. Now I know 3x to the second must be equal to 15. Guys, listen. Could I do the quadratic formula to solve this? Yes or no? Could I solve that if I move my 15 using quadratic? Talk to me. Yes. Could I complete the square? Could I complete the square on this guy? Sure. My b's is 0. Those would both be horrible and unnecessary. What's the easiest way to do this? Square rooting, right? Eventually we'll square root. So divide by 3, so you get x to the second equals 5. Square root it, x equals plus or minus the square root of 5. Do you want me to go through how to check this one real quick, or you think you're good? Who says I'm good, I don't need that? Who says me, show me? Okay, I kind of think we should. I'm going to go fast. Okay, everybody do this with me. If I take the time to do it and you don't participate, we're wasting our time. Okay? Okay, everybody do this. Hit second, x squared, 5. Close it, store, enter. Do the left-hand side. So go parenthesis. Where is the E on this calculator? Do you see it? It's above the ln. So you hit second, then you go down 2 buttons to the ln, and then you put in a 3, and then you close that, and then you close it again, and then you raise it to the, and now you have to go membar enter, then hit x squared, and then hit enter, and I got this big huge number, 3269017.3 blah blah blah. Did you get that?
Yeah.
Okay, let's do the other side. Everybody go second, ln, 15, close it off, enter, I got the same number, bam, just got it right. Okay, so you have to check both sides and make sure they match. Okay, here is question F. Okay, make them the same. Make them both, what do you want both bases to be, everybody? Can you tell? 2's, yeah. So this is 2 to the 3x, and this is 1 over 2 to the, talk to me, 2 to the third, right? But he can't be on the bottom. He's got to be at the top. So now I have 2 to the 3x is equal to 2 to the, talk to me, negative third. Yeah. So 3x must be negative 3. Therefore, x must be negative 1. Absolutely checkable. Okay? All right, question G. Can you look at that and tell what you're supposed to make both the bases? Can you tell? What? 5, right? Because 5 squared is 25. So this is 5 to the 2x is 1 over 5 squared. Take the 5 squared up. So 5 to the 2x is 5 to the negative second. So 2x must be negative 2. Therefore, x must be negative 1. Who says, I'm fine? Raise your hand. Let me see. Okay, good. Okay, I know I'm going fast and I'm sorry. I just want to finish. Okay, question 8. Do I have 7 minutes?
Yeah.
Okay, so I can slow down a little bit. The normal, you're going to see this problem again after today. The normal healing of wounds can be modeled by this equation. See how it says negative 0 point? That should just be 1 point right there. So just make that clear. So it's 0.35 n. Where A sub 0 represents the original area of the wound. A is the area of the wound after n days. Suppose the wound has an original area of 100 square millimeters. Okay, everybody listen, this is a true application of exponentials. You fall down and you get hurt and you have a wound. You have an abrasion like rug rash or something, you know, road rash or whatever. Then if everything's going great, if your body's healthy and you're taking care of it, what happens to your wound? It gets bigger or smaller? Gets smaller. What in that equation shows you clearly that the wound is getting smaller? Can anybody tell me? The negative and the exponent, right? So you start with 100 square millimeters and then it gets smaller, smaller, smaller because our bodies are amazing and they heal themselves, okay? Everybody write down A of n is equal to 100 because that A sub 0 is the initial size, okay? E to the negative 0.35 n. How big will it be after 3 days? Well, let's do this. Everybody go n equals A sub n equals. In front of the A sub n, let's put a y. In front of the n, let's put an x. I know there's no x and there's no y, but your brain thinks in terms of x and y. So A sub n is the area in millimeters squared, and the n stands for the number of days. The reason I did that is because I know this is 3 days, but I don't know if I should put it here in A sub n or put it there in n, and this explanation tells me that. Where do I put it, everybody? In n. So everybody go, A of 3 is 100e to the negative 0.35 times 3. Grab your calculators. 100, second, go down 2 buttons to ln, negative 0.35 times 3, close your parenthesis. That 3 is in the parentheses, so don't close it until you put it. Hit enter. Now, right here, I want you to write a note that says 2 digits. You would never round unless the directions told you to round, so I'm editing the directions to round. Okay, so the answer is 34.99 millimeters squared. So after only 3 days, it's gone down to almost a third of the size. It's healing well, okay? How large will it be after 10 days? So this is A of 10 is equal to 100 e to the negative 0.35 times 10. So if you hit up and then go right until you're on top of the 3, make it a 10 and close it, you don't have to put the whole thing in. Let's add to the directions 2 digits, because you would never round unless you were told, and the answer would be 3.02 millimeters squared. Okay, and that is it. Is everybody good? Okay, we still have